In this screencast, I'll be going through what is probably the last major feature of Microsoft Excel, and that's the ability to graphically represent data. So let's say I'm going to make up some numbers and we're going to make some graphical representations of those. So there's four major areas that you can go on to study in engineering after first year. So we've got mechanical engineering, which is where I'm from. We've got electrical, we've got chemical, and we've got civil engineering. And let's just say that last year we had 35 students go into mechanical, about 28 go into electrical, 22 go into chemical, and then probably about 40 going into civil, because civil is usually our biggest one. Now what we might want to do is show how this data looks in a graphical sense, so we can have an idea of scales and magnitude, and so it's a lot easier to actually absorb that information. What we want to do is insert a chart. So we go up to our insert button, and we've got a whole list of charts here. Now I'll start with a column chart. So column charts most people will be fairly familiar with, but we'll go into it here. And so Excel's pretty smart. All I had to do was select that data, and it worked out sort of how I wanted it formatted, and it displayed it for us. So we've made this chart here, and it's showing different sizes of the different disciplines here. So we've got 35 mechanical, 28 in electrical, 22 in chemical, and 40 in civil. So that's fairly easy to do. If we wanted to have a little bit more detail around this, we can choose different layouts. So our layouts are up the top here. We can change different axis names. So our y-axis here would be number of students, and this discipline would be discipline, and we might just get rid of that series there. So that's nice and easy to do, and that's probably one of the better features of Excel, is that we had some data and we got to this point of representing it graphically in very few steps. So with this same chart, and if we go under chart tools, so our design is our original type, we can change colors, change the styles that we were going through before. In our layout, we can put some pictures into it. We can add titles if we wanted to. So this is a little bit more in depth from the last screen. And here we can sort of do a little bit more to change the color of text and how that's all laid out and whatnot. So I'll let you experiment with that. So I'm going to click back on this design one, and I'm going to change the chart type. So when we click this change chart type, we can see the list of chart types on the side here. We can flick it straight into a horizontal bar chart, and it does the exact same thing. It just looks a little bit different now. We change to another one. We can go to the very familiar pie charts. This time we'll probably want to have this side on it and put some colors into it. Double clicked on that. So if you double click on an element, it will go to the formatting options, which allows for in-depth changes to what it looks like. So experiment with that if you'd like. We'll change this engineering discipline numbers, and yeah, so this is a pie chart. Pie chart is probably the most incorrectly used chart, but it's also very friendly for people to look at, so everyone seems to understand it instantly. The benefit of a pie chart over a bar chart is that it shows a more relative difference. So we know that all the mechanical, electrical, chemical, and civil students added together add up to all of the students, so this shows us fractions very well, and that's why there's already percentages listed with it. Whereas if we go back to a bar chart, we get a more absolute sort of representation as far as number sizes go. So have experiment around with that as you'd like. There's a few other chart types that are fairly similar. I will go into scatter next because that's a very important one. But spend some time, familiarize yourself with this and a few of the options, because you'll probably use this in quite a lot of assignments to come. So getting familiar with it now is a good idea. So jumping into a scatter or a scatter line graph. This is our equation before for the parabola. And so what we might want to see is a set of values for x and a set of values for y, and actually plot that. And it's how I made the graph that you saw in the second screencast for this week. It was doing this exact process. So with an equation like this, if we want to graph that or graphically represent that, one of these two values is going to have to be fixed. So either we go through a fixed set of x values or we go through a fixed set of y values. And because the way that our equation is set out, y is here by itself, it's going to be much easier if we go through a fixed set of x values. So the other things that we'll need is a, b, and c, and mimicking what we had before, a was 0.5, b was 1, and c was -5. So our values went from, previously went from -10 to +10. And so that would be quite a pain to actually type out. So there's thankfully a shortcut. So I'll start with -10 and I'll go to -9.9. And so if we wanted to go from -10 to +10 in steps of 0.1, then we've got a good 200 odd values that we'll have to type, and we don't really want to do that. So what we can do instead is select these two, so we can see that it's already started a pattern, and ignore that one. So we can see that it's started a pattern. So we select those two and see this little box that's down on the corner. This is a little autofill feature. So we can drag this downwards, and I don't know if you'll be able to see it in the quality of these videos, but a little tooltip is coming up just to the up and right of my cursor. That's telling me which number we're up to. So it's down to -9, so I'll keep dragging downwards. And when we get to +10, we'll know to stop. So there we go, so +10, cell 202, which sounds about right. And Excel has automatically filled in all those values for us. So that's particularly helpful. There's one here, which looks really, really strange. It's -4.1 times 10 to the power of -14, so it's very, 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 very close to 0, but not actually 0. You'll find out later in the subject that floating points, so floating points are how computers store decimal numbers. There's always a little bit of rounding error with decimal numbers, and that's what we see right here. This value should be 0, but it's not, and you don't have to, because it's close enough to 0 that it's not going to matter. I'm just going to change that to 0, and that's done. So what we've got to do now for the y values is put this equation in instead. So I'll put it in equals a multiplied by x squared plus b multiplied by x plus c. And so that works. Now, the same thing with this equation, we can drag it down. Now, there's going to be an error. I'm doing this intentionally, but that kind of goes AWOL very quickly, and we've got to find out what's happening. So if we click on this bottom one, it's saying D8 multiplied by A8, so A8 is our X value, but what's D8? There is no D8. And so what's actually happened is that the pattern it's trying to replicate is moving these cell references down as well, and that's not what we want. So what we can do is, when typing in one of these equations, so currently it's thinking that I'm working with cell D2, we can press the button F4, and it's put these dollar symbols in front of the D and in front of the 2. Now we can type those by hand as well, so I'll do it for those ones, but I'll just press F4 again for that. And what that actually does is, so it hasn't changed the answer, it fixes those cell references. So if we want to do a fill operation, which is what dragging this little box around does, it doesn't actually change them. So when we go down, everything's looking better. Now if we go onto that one, we can see it's still D2 with the dollar signs around it, still D2 with the dollar signs around it. So what those dollar signs are doing are fixing that value in place, and that makes it a lot easier for us. So clicking and dragging this whole thing down so we get it all the way to 10 gives us a whole lot of numbers. So this is our parabola, these two columns. We've got X values and we've got Y values. And so let's actually see what that looks like. Now, most people would be fairly tempted to go into a line chart right now, but a line chart only allows you to have one column of information or one row of information per line, whereas a scatter chart allows you to have X and Y points. So there's a little bit of a difference, and I might actually just show you quickly. So if we automatically select those two things, go into line chart and click on that, it's treated them as two different series. So it's got the X values and the Y values. Now the Y values actually make up a parabola anyway, but it's not to the right scale. So it should be between the values of -10 and 10, whereas this one's doing it between the values of 1 and 201. So that's not particularly helpful. So let's try this again. So let's change our chart type to a scatter. So a scatter can be a set of points. It can be a set of points with some smooth lines around it. It can be just those smooth lines. It can be straight lines. Now, the difference between straight line and smooth lines is that smooth lines will bend the curve a little bit to make it look better, but it might not be accurate, whereas straight lines might be more accurate. But we've got enough different points that both the straight line and the smooth line will probably look the same. So I'm going to go with smooth line because you'll probably want to do that most of the time. Now because we already started in line version, it already has sorted out, has put our data in that sort of format for us. So what we can do is, with our chart selected, we can go to select data, and this lets us actually change the way that the data is set up. So I'm going to remove both of these legend entries, which is the left side, and then add my own. So the series name, we'll call it parabola. The X values are going to be from here to down here. Now in here we can see that it's put it in as a formula. Now you can also reference between sheets, which I haven't told you before, but between sheets we put the name of the sheet surrounded by apostrophe marks, then an exclamation point, and then the actual cells. But most of the time it's going to be easier just to select them. So once we've selected that X data, we click back, and then we go into our series Y values, and we select this one. We can get rid of that, and quickly do that. and then we have something looking significantly better already. So we'll click OK on that, and click OK on this, and we have our parabola drawn. Now, because our data only goes between -10 and +10, we might want to change the scale or the x-axis points on here. So we click on the x-axis itself, and then right-click on it, and then click Format Axis. It'll take us into this option. Now, there's heaps of options, which I think you should go through yourself and see what they all do. But the one I'm going to look at here are this minimum and maximum axis options. So at the moment, they're set to auto, and I'm going to change them to fixed. So instead of -15, I'm going to have -10. And instead of 15, I'm going to have 10. So you can see it changing in the background already. And here we go. So it goes from -10 to 10 now, and that's our parabola drawn. So that's what we had before. It's correct. That's what it should be. And we've now experimented with some charts. So with these 3 screencasts now done, you should have more than enough information to complete everything that you need to do for the first week's lab. So good luck, and hopefully you enjoy yourselves.